Hello, hello. Can everyone hear me? Nice. So I can hear myself because I have YouTube open. Nice. Good morning, everyone. I'm just gonna delay this a little bit, just get waste some time so we can have the latecomers arrive. In the meanwhile, please find the announcement of this on Twitter, on X, on YouTube, and share. Give your like. I'm so excited about this. Best Cartesian haircut. I almost got a haircut in advance of the experiment week, but I was too focused on learning about coprocessors, so I skipped that. But expect me on demo day with a sharp haircut. But don't hold me accountable to that. All right. Let's see. We're live on X already. Are we? We are. Cool. I'll give it one more minute, and then I'll start my presentation. Morning. A lot of Cartesians around here already. Some people are sending me private messages laughing about my haircut. Thank you, Anderson. All right, let's speed this up so you guys don't comment about my appearance anymore. But I'm rocking the Cartesi t-shirt, simple-minded. I was gonna rock an EigenLayer one, but I don't have one yet. So if anyone on the EigenLayer team is listening, I'll send you my address. You can give me some swag. All right. All right. So maybe let's start. Can I get the presentation up? People in the background. Nice. This Nida is so efficient. All right. Hello, everyone. Such a pleasure to be here again. This is the third edition of our experiment week. This time we will have a lot of new faces. The experiment week this one is by far the largest one. So let me introduce myself. I'm Felipe. I'm a Cartesi guy. I love Cartesi, and I'm going to be the host of this experiment week, as I was for the ones previous. And this slide in the presentation will be a very reasonable slide for the third edition of our experiment week. But thanks to a lot of amazing and hardworking people, this is the real slide. That's right. This time we have our friends from EigenLayer. They're joining us for this very exciting week. So welcome. It's much better to do it with friends. I'll allow you some seconds to clap at home. All right. Super exciting. They're going to join us. We're going to join forces for this experiment week, third edition, Cartesi and EigenLayer. All right. So let's go over the agenda real quick. We'll start with some quick words about the experiment week and what's coming. I'll try not to take too much of your time because, well, right after that, we'll have some super cool presentations. Cartesi's founder, Erick de Moura, who's going to talk a little bit about what Cartesi is. Seems obvious, but it's always nice to hear from the founder himself what it is. And then we'll have a Sreeram from EigenLayer. He's the founder of EigenLayer. Lovely guy. He's going to be presenting on what EigenLayer is. Then right after that, Joao from DevEd, our very charismatic Joao is going to talk about Cartesi plus EigenLayer, coprocessors, workshop demos, and cheat codes. So this is the part that hackers should be excited about. So what is experiment week? That's the goal of my presentation. So if you zoom in, the experiment week is actually a very simple concept. The experiment week is a week-long hackathon to build and submit projects. It's a time for us all to get together, explore the infrastructure we built, explore the cool things we're building. And it's a moment for us to validate and improve our dev journey, right? So, but if you think about it more carefully, or at least more poetically, you'll see that what actually is the experiment week, right? The experiment week is actually a moment for us to step back and question the deeper purpose of what we're building. It's about understanding that technology and infrastructure, they don't have value on the abstract. They have value in the real utility that they generate, right? So code only holds value when it's used for important things. So the experiment week is actually a moment for us to sit back and ponder about that. It's a moment to celebrate our achievements, celebrate what we accomplished, celebrate what we built, celebrate our collaborations, and celebrating each other as well. And also, of course, to have fun in the process. So it's a week that is also a little bit dedicated to fun and craziness and experiments and so on. Well, hence the name, Experiment Week. Shouldn't be too surprising. Uh, and it's an invitation to rethink how we'll create real impact. It's not enough to build some super cool tech. We also have to teach the world how this tech can have real impact, right? And it's so nice to have our friends of us here today, EigenLayer, that kindly join us to achieve all those goals. Experiment Weeks, the celebration is actually the first phrase of the first Experiment Week kickoff on the opening uh, edition of the first Experiment Week. It was the 2nd of November of 2023. And at the time we were celebrating Cartesi rollups being mainnet ready, right? We had just launched the Honeypot. We had Cartesi rollup on mainnet. And it was an opportunity for us to get together, to eat our own dog food, to learn about the very own things we created. And the OGs here will remember the state of the dev journey for rollups at the time. It was quite hard to code. We still had a lot to improve on that front. And today, the dev journey for rollups is much improved. And a big part of that is because of the experiment week. So because of what we learned on the experiment week. So that goes to show the importance of this event. Today, we are in a very similar position. Uh, we are here to experiment with Cartesi coprocessors, right? So Cartesi coprocessor is in a bit of the state that the rollups was back then, a very promising application, a very promising product with an experimenting dev journey, a dev journey that needs improvement, but is in a state in which we can all play with it and we can all have fun and we can all create meaningful things and help it improve. Right, a quick background on rollups and coprocessors. They're both ways to extend to the blockchain the ability to perform computation in our very own super amazing Cartesi machine. So they both achieve that. The main difference between these two is that rollups are stateful off-chain systems, while coprocessors are stateless off-chain systems. And this is actually a quote that I got from Sreeram's tweet, I think 1 or 2 years ago when he was explaining coprocessors and optimistic coprocessors. I'll share that X thread on Discord for you to take a look. But yeah, so take this week to learn more about coprocessors. Take this week to learn more about EigenLayer. And those in the EigenLayer community, take this week to learn more about Cartesi. So take this week to look around and think about how the awesome things that we've been creating can be shared in more impressive and different ways, to explore, to experiment, and to improve coprocessors, just like we improved rollups. So I'm super excited to see that happening, and I'm super excited to see what we'll cook. A quick trip down the memory lane. This is what happened on the previous 2 editions. I'll give you some seconds for those who participated to find your projects there. You can see like Arena Mayhem. There's Comet there, Blob Chat. There's DFast. Rumors. The rumor around DFast is that the judges were not fair to them. They actually implemented a lot of cool things and they did not get a prize, but they actually built something quite incredible. And I can say that because I was one of the judges. So shout out to DFast, Tamagotchi, so many cool projects. But paying special homage to the winners of the first edition. Bugless, now it's called Bugbuster. Super nice project, impressive mechanics. They're actually still around, improving and releasing. It's been more than 1 year since the first experiment week, and they're still out pumping releases, updates. They're now called Bugbuster. Truly recommend everyone to check out their X. They now allow you to upload, deploy Solidity smart contracts, and create fully decentralized bug bounties on top of that. Second place went to Cryptopolis. The madman just went ahead and ported SimCity, the original SimCity, to Ethereum, to the blockchain. So cool. Uh, I think there's a dev team that took over. It's all open source, right? So a dev team took over and they're pushing it forward. I don't have too much information on that, but if you know the devs who are doing that, please post them on Discord as well. So nice to see that happening. Third place went to Lambda DEX, a bare metal, verifiable exchange, decentralized exchange. So they actually implemented an order book that runs on the blockchain, fully verifiable, and with speed of bare metal. So sad that didn't go forward. If there's any devs out there that want to take this prototype and build it, I do believe it's huge potential. Now we have the winners of the second edition. First prize went to Eduardo, the machine accelerated kernels. That was a not so much a dApp, but a legit scientific endeavor. It was basically a study on how to perform inference of large language models inside the Cartesi machine. That was super cool. The videos on YouTube, you should definitely check it out. It was a hell of an engineering effort. Second place went to Comet, the most beautiful presentation, I think, to this day of all the experiment weeks. It's a co-writing, co-creating platform. They're still around as well. You can check their X profile. And third place was a draw between organic yield farming and on-chain. The first one is a yield inflation auction, super clever mechanism. And the second one was on-chain chess running on Base. They did such a great work on UX, so definitely recommend checking that out as well. They also have a X profile that I should have included the link, but I did not. All right, I'm running out of time, so speeding up a little bit. So have rules and information. I'm gonna just fly through these slides because we can find all the information out there in the written form. But the start date is today, exactly right now. The end date is February on 16th. All submissions must be received by 5 p.m. UTC. And we'll have a demo day on the 17th of February, right? So selected submissions only will be invited for a longer presentation on the demo day. So on that folio, you'll be able to find the rules of submission. We'll do a pre-selection, and those selected projects will be able to present in a longer form. And from there, our winners will be chosen. These are going to be your judges. It's me, Felipe, also a co-founder of Cartesi, as Erick is reminding me on the on the chat. Brandon Isaacson, a board member of Cartesi. Nader, the great director of EigenLayer advocacy, a developer advocacy on EigenLayer, super cool guy. And Ishan, the protocol researcher of EigenLayer, one of the most upbeat persons I've met in this space. This slide, some of you really care about this. Price is up for grabs. First place is going to be $6,000 in TSI and Eigen tokens. Second, $4,000. Third, $2,000. Other prizes might be available at the Cartesi's Foundation discretion. And QIC will be required for non-grantees who receive a prize. So these are the channels and important links. Go to Discord, Cartesi Discord. We have a category for the experiment week. We have 3 main channels, info and updates. There's where all the updates are going to be posted. It's the most important channel for you to be up to par with everything. We have team formation and idea sharing. Please go there if you're looking for a team, if you're looking for a teammate. Share your ideas and the coprocessor support. That's all available on the Discord. I posted the QR code there. And we have 3 smaller QR codes here. Devfolio, where you can register your team and submit your application. All the important rules are there as well. We have the docs that our dev team and ZP formed. Super cool. Please read it, use it, and give us feedback on it. That's what one of our main goals for this experiment week is, to improve those docs. And we have the announcement blog post where you can read a little bit about the story behind the experiment week. You can read a little bit about EigenLayer, Cartesi, the coprocessor, and so on. Some closing thoughts before I take too much of your time. Please have fun. Don't overwork yourself. This is a fun event, a team building event for us to create cool things. Share what you're doing. Last time I had such a cool experience with some teams were sharing on X, live tweeting their accomplishments, their codes, their hurdles, and they actually got a lot of like interested people watching and looking to help. So share what you're doing, share it on X, share it on Discord, get help. Collaboration over competition. I know we have prizes. I'm a little bit against them, by the way. This is about collaboration, not competition. So help each other out. Some teams are going to be both hacking, but also providing support. So spend some time to give advice, to help each other. The important thing is to build cool shit. It's not to win the prize. A huge kudos for everyone involved. This experiment week is orders of magnitude bigger than the previous ones, and there was a lot of work in the background. So DevAd, ZP, Pio was coordinating all this insanity. So huge kudos to Pio, the Cartesi Foundation and marketing unit. There was a lot of work to make this happen. And thank you for EigenLayer as well for joining forces, coming to talk here, helping us judge, contributing with prizes, amplifying the events, and so on. So being great partners on this experiment week. And let's have fun, let's hack, let's give our best, and let's keep in touch. And that's it. That's the presentation I had. Now I think we'll bring our very own Erick Moura to talk a little bit about Cartesi.
Hello, everyone. Thank you, Felipe.
Hello, Erick. That's a nice background you have.
Yeah, it's a real wallpaper.
Nice.
Okay, so nice intro. Thank you very much. Thanks everyone for being here. It's a big honor to be here today. It's for sure the biggest experiment week that we had so far. When we started the experiment week, as Felipe said, well, we were doing only ourselves inside of Cartesi, mostly with our core developers and a few other developers from the community. We thought it was so amazing, the results were so great that we want to extend that over to partner projects. So we are now doing with EigenLayer. Thanks a lot, EigenLayer. I think it's going to be great. I'm very excited. I think all of us are very excited for these moments, for this week. You know, I think since last year, when we were walking around in conferences in Web3, we started to feel that vibe that, you know, people are feeling that it's not enough to build amazing infrastructure. Things like build whatever. I give you the infrastructure now, build whatever. Is not good enough anymore. And you know, we at Cartesi are just trying to do our part. You know, having our core developers, our team, our community, stopping what they're doing for a week to come down to the ground and try to conceive new use cases, experiment with new things. And it's amazing when partners like EigenLayer want and are excited with this idea and join us in this task. So I want to talk to you a little bit about Cartesi. Probably most of you already heard this over and over again, but maybe there are some new people hanging around here. So what's Cartesi, right? I think in a single sentence, the way I see Cartesi today is that it's simply by far the best execution environment for Web3. And I truly believe that everybody working at Cartesi, starting from Felipe, for sure, is working at Cartesi because we really trust these statements. We trust that we're bringing something that's quite unique. And since when we started in 2018, we were kind of waiting for this moment. We were a bit ahead of the game, I think, in that sense, that blockchain one day would come to a point in which we could not just like turn our backs against mainstream software, against all the infrastructure that has been built for everything up to Web 2, right? Because when you come to blockchain VMs, we have new VM architectures, we have new idiosyncrasies of programming, new things developers have to learn, and people have to reinvent the wheel all the time. And it just felt that would come a day in which people would want to develop Web3 applications, pretty much like they develop Web2 applications on a real operating system. So we believe that time is now. I think it's starting to happen. Finally, I have some water. So going a little bit back in time, let's say about around 10 years ago. 10 years ago, Ethereum came up as the first blockchain supporting so-called Turing-complete programmability, right? And 2014, people were calling Ethereum as the world computer, which turned out to be a kind of a stretch, kind of a bold statement if we consider the crazy scalability constraints that a blockchain would have to run large computation or to hold data, right? So if you compare the computation capability and data availability of blockchains, layer ones, they are orders and orders of magnitude inferior compared to what we have on the most basic Linux server or even on your laptop. So it was clear that maybe the world computer is not the best analogy. People started to call Ethereum a kind of a vending machine, kind of a digital blockchain vending machine, and it was cool because even a blockchain that supports elementary, very simple computation, a low capacity of data, because of the properties of blockchain, decentralization, neutrality, security, there was a big euphoria and new things were possible, even under those constraints, right? So we saw all the euphoria about around money Legos coming later. So starting in 2017, we had MakerDAO, stable coins running on Ethereum. 2019, Uniswap came. And then 2020, there was this whole euphoria together with the bull run, with compounds, year-end finance, and all these things that were like money Legos back then. And it worked quite well. Later we had NFTs, digital properties, all these things coming. But, well, we saw that was a certain moment of euphoria, early experimentation on Ethereum and blockchains. And we knew that at some point we would have to shift gears, right? The industry would have to shift gears, come out of this experimentation zone. DeFi one day will not be niche anymore. We'll have to achieve mass adoption. And we were looking for like mass adoption use cases, new applications, and would come a time in which things would be different. So we would have to move away from the infancy of niche DeFi, monkeys, punks, all these things, to have like applications that would eventually like make a big impact in our world. So we have been basically building waiting for these moments, right? We also established ourselves as a scalability solution, as a computational scalability solution. But the thing that we really wanted to do is to bring a VM, a blockchain VM, that would run Linux, right? That people would be able to develop their smart contracts using basically the same software stacks, libraries, components they already use when they program for Web 2. So why? Think about it. Web 2, if you take any great application on Web 2, whatever you like, Uber, Airbnb, these applications were not built in isolation. Developers didn't start code everything from scratch. They were developers developing on the shoulders of giants. They reuse a lot of software that was built throughout more than 40 years, basically, right? If you think about Linux and all the open source variety that they could rely upon libraries, frameworks, SDKs, everything. Those things took 40 years to mature. And of course, billions of hours of engineering work from lots of people. And we can also say untold trillions of dollars were spent to create this great infrastructure for Web2 to thrive. So Web2 really only could exist because of this very rich substrate that was there. Now, when you come to Web3 and you invent new VMs, we are severed from all this tradition, from all this legacy, and now the developers have to implement things from scratch again, starting from logarithm functions. Like it's really like a huge setback, right? So we were kind of seeing that in 2018, like, okay, it's great to have much better computational scalability, you have to have much more data availability, but is that enough? We didn't believe that was enough, because once we have all this computation available, all this data available, the next question is, can we have a runtime, an execution substrate that's comparable to what we have in Web2? If so, why not, right? So we bet on this assumption, this hypothesis, which was not an easy choice. Like it was tough for Cartesi to survive those kind of 5 years, like building and waiting for the moment to come. But we are growing more and more confident nowadays that the moment is coming, right? And even the partnership with EigenLayer is evidence of that. That now is a moment that, on the one hand, people want to see real shit, like mass adoption for real Web3 applications. We owe, like collectively, we in the Web3 industry, we owe that to people out there to bring real utility to the infrastructure we have been building with a lot of sweat and tears sometimes. But we can do better to show some ways, some use cases, some new possible horizons. So basically, Cartesi has been then building not only this VM that runs Linux and allows people to develop with mainstream software stacks. So that's why I say we are confident we have the best execution environment for Web3. We are also building state-of-the-art fraud-proof, right? So that's another very important component that I want to raise here: the VM and the fraud-proof system. And so our research team has developed two algorithms, Dave and PRT. And a lot has been discussed about these. You guys can check it out later on. Basically, L2Bit in the recent article, Fraud Proof Wars, has considered and has seen that Cartesi algorithms compared to both from Arbitrum and Optimism Fraud Proof, optimizes is the best option when you want to optimize for security and decentralization, right? So we are very serious, not only in developing the best VM for the future of Web3, but also fraud-proof is really one of the most important pillars, if not the most important pillar, of all that we're building. So those are two basic elements of what we do here. So yeah, those are the things I want to tell you about Cartesi. Super excited about what's to come. Very happy to have all of you here. And yeah, I think Felipe said all the rest. Please don't be shy. Share whatever you can in the Discord channel. Let's make it as alive as possible. Sharing questions, asking questions, or sharing knowledge. And I think it will be great. I can't wait to see. I can't wait to talk to you guys throughout this week as well. So, Felipe, I think that's it. Any other question?
No, I think what is Cartesi was the question. I think you answered it perfectly. I love the storytelling, the historical explanation of what we've been building. I fully agree that we are the best execution environment and the best fraud-proof algorithm out there. But it's lovely to hear again the rationale behind the choices we made and the design space that we chose. I think that sometimes we zoom in a lot and forget to zoom out and look at what brought us here. And yeah, I'm so excited to see what's gonna be built. Thank you so much, Eric. We'll
Thank you
talk
so
more
much.
during this week. And I think
All
now,
the best, everyone.
awesome. Bye bye. Now I have the pleasure to speak. So the first two editions of the experiment week, we did it by ourselves, right? We were a very small project. We had just gone mainnet with our rollups. We were experimenting with our own dog food, improving the infrastructure. And this time we decided to do something different. And we invited our friends from EigenLayer uh, to come and help out. And so Sreeram is here to tell us a little bit about what EigenLayer is. Hello, Sreeram. Welcome and thank you for coming.
Hi Philip. Awesome to be here. I'm sitting in a car, but not driving, so it's not unsafe. Um, Pleasure to be here. It's great to hear Eric speak about the history of Cartesi. Maybe I'll start with a kind of like a brief introduction and like what about myself and EigenLayer. I'm Sreeram. I started the EigenLayer project now like 3.5 years back. Used to be a professor at the University of Washington, Seattle, where I ran the AW Blockchain Research Lab, working on consensus, scaling, game theory for blockchains. And one of the reasons we started EigenLayer is the you know even just the name Eigen in German for your own layer. So the core idea that we wanted to enable is anybody should be able to come and build whatever they want. We say one of our driving values is open innovation. Open innovation means the ability for anybody to come and innovate as an equal on the global stage and build cool and new useful things. The reason I started EigenLayer was, you know, at the University of Washington, we were running like all these building new kinds of consensus protocols, new kinds of um, you know uh, middleware and tools, scalability tools for blockchains. And what we found is that the barrier to entry is insanely high, right? So if you want to build something new, you have to actually build a whole new layer one system. If you wanted to go deeper than than just building a smart contract on a blockchain. And so this made it very difficult for people to come in and innovate at different layers instead of having to innovate at all layers all at once. And so that was the kind of like core motivation for EigenLayer is can we provide a common trust network? And the way EigenLayer works is by, if you look at how Ethereum or any Solana or any proof of stake protocol works, you have a bunch of stake. Uh, People lock in their assets and then promise that they'll run the network correctly. And our theory was like, why can't we just make that shared across all kinds of different networks that can then be built on top? And so that's what happens in EigenLayer. People stake ETH and or other digital assets and then make a promise that they will run, they're free to opt in to support any new networks that can then be built on top. Okay, so that's the core kind of like base level of what EigenLayer is. One of the first services that we built on top of EigenLayer is EigenDA, which is a data availability system. And Eric was talking a little bit about data availability, but a simple way to understand data availability is to think of, do you have, as a user, assurance that you can read from the network? Because imagine that you're building a system with fraud proofs, and if you're not guaranteed to be able to read from the network because somebody colludes to withhold the data and so on, then um, then you don't get the assurance that if there is something going wrong, somebody can trigger a fraud proof. So data availability is a core fundamental thing. And so we built EigenDA, based on the Ethereum roadmap. In the Ethereum roadmap, there is a data availability system called dark sharding. And we took the same protocol, but then just scaled it up and built it maybe 3-4 years ahead. So that's what EigenDA is. It runs at 15 megabytes per second. That's 120 megabits per second. And I think it'll be like 300 to 500 times faster than Ethereum, and at least 10x, likely like 20x faster than any other data system in crypto. Okay, so that's EigenLayer, EigenDA. And I'll speak to a little bit why we're very excited about this, running this hackathon with Cartesi, as well as what the potential is. So when we talk about open innovation, the core idea is that any developer in the world should be able to come in and build something new and interesting for crypto. And if you look at it right now, inside crypto, inside blockchains, you have maybe like 20,000 developers. So that's what the Electric Capital Developer Report covers, is the 20,000 developers. And this is an insanely small number. Compared to what? Compared to the 30 million plus software developers that are there in the rest of, computing. So we are, in terms of developers who know how to program blockchains, we are still talking about less than 0.1% of all software programmers. This is not a way to like build for everybody. If you want to build for everybody, they should be able to bring their own programming languages, tools, and stack that they're already comfortable with. And so that's really why we're super excited about this partnership with Cartesi. Is the way you break it is by removing the barriers in the programming environments. And the core thing there is, for example, in Ethereum, you have the Ethereum virtual machine. You have to write programs that fit into, and it's built on Solidity. It's a new language for people to come and learn. And as we move from very simple applications built for decentralized finance to all kinds of applications that now want to be verifiable and autonomous, you can actually start building a lot of them on the Cartesi virtual machine. So, which is something that we're super excited about. And many of you here as some of the earliest developers in this new upcoming paradigm. If you master this, if you actually build new and interesting applications here, suddenly the aperture for what can be built has gone up massively. So you developers early in this movement have an asymmetric advantage as you build these new applications, because there are two views to crypto. One view is crypto is just a financial or a payment rail, and the other view to crypto is it's make all computation verifiable. And so we come from the second viewpoint. If you want to so imagine you want to build a game for the metaverse, right? And Cartesi had an early demo on chess, right? If you want to build games that are verifiable, so I want to run let's say a gaming tournament on chain, and then like give the winner a bunch of like digital assets or NFTs or whatever the outcome might be. How do you make these games actually verifiable, as opposed to like you have to trust somebody that the game actually ran in the way that we said? You can do all these things on these blockchains, and with these massively increased programmability, because now you can actually run almost a Linux virtual machine on a blockchain rails. So super exciting, and really thrilled that Cartesi has been, here through the bull market, bear market, continuously building, right? So it's when the weather is good, and then they just vanish when things get tough. And I think Cartesi has been here through the bear, building new and interesting things. So really excited for it, really excited for all of you innovators and developers. Like I said, our core value is open innovation, the ability for more developers to come in and express new and interesting things. And so really excited to be here to kick off this hackathon.
And that was an awesome speech. I do have some comments, since you brought up why it's nice to partner up with Cartesi for this experiment week. Let me say a few words on why I think EigenLayer is also a great fit for Cartesi. And I think you've touched on a lot of them, right? First of all, the open innovation is a principle that matches the experiment week perfectly. That's what we're doing here. We're all stopping a little bit to figure out how can we innovate, how can we experiment. what cool things you can build. And it's quite interesting. The Cartesi machine is super nice for that because of an underrated feature that I think of a lot, which is the forward compatibility, right? So I think you touched very well on this idea that you can use like all the toolings and libraries that people already know how to use. So you bring all this new wave of developers. But in reality, the Web 2 world also keeps advancing, right? And if you look at AI, for instance, you see every week a new model comes out faster and more scalable and so on. And through the Cartesi machine, you also get access to that as soon as it comes out. Well, sometimes you have to cross-compile it to RISC-V, but that's fairly easy to do for the hackers out there. But one key aspect of EigenLayer that you touched is this idea of anyone being able to spin up a new layer, right? And Cartesi, because of scalability reasons and also security reasons, has always targeted app chains, right? So for app chains, you have to, every time you have a new app, you have to spin up a new chain. So you have to spin up validators, and it's a fraud proof, so you have to be sure that you have at least one honest validator online out there. And what EigenLayer allows us to do is to delegate this node running aspect to someone who is economically invested in it already, right? So someone that has restaked economic value that can watch over your chain for you. And that's super cool for both app chain rollups and also for coprocessors, which is a stateless version of the rollups in a way. So super excited for this, Sreeram. Thank you for coming. Hope to
Thank you,
hear
Felipe.
from you.
My pleasure, and look forward to all the cool outcomes from the experiment.
Awesome. See you around, man. Thanks. Cool. That was so nice. I hope you guys all enjoyed that. Uh, Sreeram does such a great job at explaining what EigenLayer is in the context of the whole Web3 ecosystem. It's lovely to hear from him. And now, if I'm not mistaken, we'll have our very charismatic dev ad lead, Joao, who's going to come here and present, give us a workshop, a demo, and the things that hackers are excited about. Joao, where are you at?
Hey, how are you? I don't know about charismatic, but thank you for the intro.
What's wrong? The stage is yours, man.
Stage 9? All right.
Yes.
So let me share my screen first. And here I am. Okay, everyone. Sorry for the screen inside screen. Wait, I think I'm sharing it incorrectly. My bad. All right, now it's working, and now you can see it. Sorry for the confusion. I don't think master's degree and 2 bachelor's degree in computer science really help you to understand how a stream works. But all right, here I have the main introduction for you about all this integration, which thankfully I don't have to go through in depth because Felipe just gave a very good explanation of why this synergy is so important, right? Between the Cartesi machine, which Erick just put a very good explanation on, and EigenLayer, which thank you, Sreeram, for explaining exactly what is the whole intention in all of that. So besides the introduction, I think this is a very important page for everyone to be accessing in our docs. And the link for that is docs.mugen.builders /Cartesi Coprocessor /introduction. I will try to, Nida, can we put it in here so we can show everyone the link for the documentation? It's the same one that Felipe shared with the QR code before. And you can see the difference between our product Cartesi rollups and the Cartesi coprocessor that we're building right now. I think this is one of the most important things to be attentive to and understand the intrinsities of Cartesi coprocessor being stateless. So you do have to maintain state in the application smart contract. The advantages on the security model by leveraging the EigenLayer cryptoeconomic security, different use cases like that are enabled by this, such as fast finality, which is a huge boost to everything that many applications that we always wanted to have deployed. And there are many different ways to build and develop with our stack, right? So of course you can go by different sections here. Navigating, understanding the architecture is very important, and I really like this second drawing here to understand all the components that are present in this solution. So you can think of all the agents here, right? The user calling a function to a regular smart contract. You just interact it as you would be interacting with any smart contract deployed on Ethereum. From there, you can call this issue task event, where the Cartesi Coprocessor smart contract will emit the issued task issued event. And the solver, which is this agent, will be looking for these events and activating operators to compute the machine that is delegated in all this operation. So it's one single line, it's one single stream that where the information flows to go from your user to your smart contract to your Cartesi machine. And all this result is sent back in the same way, in the same pipeline, and the user can read the computed results from the smart contract. So this might be a little abstract. So before showing the rest of the documentation and showing the options you have on how to develop and how to implement your own application, I'm going to give you a little showcase in here of how the application looks, right? This is a very simple smart contract, which is called Survivor Caller. The idea of this smart contract is for you to be able to test if you would be a survivor in the Titanic accident or not. So what you can do in here is just send an input to this run execution function, and this smart contract calls it inherits the coprocessor adapter interface. So there you have the call coprocessor function, which activates the Cartesi coprocessor. So basically by calling this, you're going to be spinning up a Cartesi machine to performing all the complex computations you need, and all of these computations will arrive in your dApp. In this case, my dApp here is a Python dApp, which has this classify function, right? This classify function just calls a simple model, which is a logistic regression model, and it uses the very famous data set that is Titanic Survivor. So just by sending the age, the sex, and where the person embarked on, you can have the information if they would or would not survive the Titanic accident. So it's a very simple handle advance in here, where I open this input, I read the data that's in the input, and I activate my model in here, just calling a .score function and getting the score if my survivor, if my agent, my person information, if with that person's information, they would survive or not the Titanic accident, right? So it's a very straightforward interface. And the ways you can build and test it, I'm going to give you a little video of a showcase, but then go through all the alternative tools that we can think of. So this is just me in a regular front end connecting my wallet, interacting with it through MetaMask. And there I can see that I have already spin up in my local environment all the components of the solutions that I mentioned in that architecture, right? The solver and the operator. So if you watched the Titanic movie, you would know that old men were the least prioritized to be saved in the accident. And in this case here, I'm sending this information. The solver is observing that the issue task event was emitted by the smart contract, and there it delegates that machine hash will be activated with this input information. If I look exactly what this input says, it's what's on my front end, just for the sake of being sure that the information is arriving safely. And I can go then finally to my operator to see what's happening under the hood. So this is essentially the logs of my Cartesi machine. I get the information. I even print in my code, I will show you later, the information of the passenger. and I can perform the computation and get the results by adding this component, which is a notice. So this specific person would not survive well the Titanic accident, right? It's very important to notice that this specific application is a very simple one, just to illustrate and give you an idea, to light that spark on the back of your head to what you can or you can't build. In this case, I did print here received input, and then I printed data and predicted results. So it's the exact same log that you've seen in the demo, right? Just putting up here the demo again. It might be a little small to zoom in. I don't know if you will be able to see it, but yeah, you can see that it's the exact log that the application sent. So it's a very simple way to see the results while you're building. You can just check your Docker desktop. So how do you build? How do you start your development journey? Well, we do have a guide of installation. All the components that you need, they are 4 main components. So it's the coprocessor CLI, the Cartesi CLI, Docker desktop, and Foundry. So there are 3 main ways where you can tackle this. My suggestion is go through the CLI. The CLI really abstracts a lot of the process. So we put all the building and compiling and deploying to your local testnet, even spinning up your local DevNet inside the CLI. So you can simply say start DevNet or stop DevNet if you want to stop. Then you can create your smart contract, add your logic in here, add your logic inside your template, and from there you will be able to start coding and testing however you want, just through very, very simple instructions. So Cartesi Coprocessor deploy, Cartesi Coprocessor publish, start DevNet, stop DevNet, that's all you need. And then to deploy, the Cartesi Coprocessor CLI also takes care of that, right? It's a very simple Cartesi Coprocessor publish and directing you towards the network where you want to publish. Right now, we are supporting testnet and mainnet just directly through those flags, testnet being host key and mainnet being Ethereum. If you want to cook something a little more crazy, because oftentimes in these experiment weeks, we do that, we see people creating tooling around it. We left here also the manual approach, right? So that means you are using all the components that create the CLI, that constitute the CLI, manually. So you're spinning up your DevNet manually, you're compiling and building the Cartesi machine manually through the Cartesi machine executable. So you can start to create and juggle with it a little bit, create alternatives, adapt the framework to however you prefer and however you think it's best. And if you're having trouble debugging, I highly suggest you using NoNodeOS. NoNodeOS, it's an adaptation of NoNodo, which is a tool that we use to experiment with Cartesi. And now we have it for Cartesi Coprocessor as well. What you do is you install it from this repo right here, and you spin up your own Anvil, you run your NoNodeOS, and you are then able to run your coprocessor application directly on your computer. So this way you can hit some breakpoints and debug in case you're having any trouble. Don't think you will, since you already have the logs from the coprocessor, but NoNodeOS does have some advantages as well, like using a different version of the Cartesi machine. You do not necessarily have to use the one that is in the coprocessor CLI, and you also can perform some tweaks, and it's faster to spin up and spin down your own local testnet, your own local DevNet in case you need to, right? Then we have a whole section on how to interact. It's pretty simple standard smart contract interaction. And I really highly recommend you to understand better, read the known issues and limitations, so you can tweak and shape your idea, whatever your deliverable will be, to these limitations, or even take inspiration on those limitations to what you're going to build. Talking about what you're going to build, highly suggest also you go into our Discord. Bruno posted in the channels We have 3 channels for the Cartesi Coprocessor Experiment Week. We have and Bruno posted there some suggestions of what you can actually build, being those some very creative ones, and of course logistics, social networking, a risk calculator for credit, for example, AI agent, routing in like smart cars, decentralized Uber, or similar solutions. And now going to our resources, I would really like you to always check our Mugen Builders repository, our organization, and there we have many repositories that might assist you in this journey. We have an end-to-end template that counts front-end, smart contract creation, and even the Cartesi machine logic implemented in JavaScript, Python, and Rust, and Go for a very simple counter app. But it's a good structure for you to start working on, right? So you have here all the smart contracts, all the UI implemented, and many options with different languages and templates to build. We also have the Titanic Survivor, which I just showed. Same thing as the counter. In this case, we only have the Python implementation, since the model that I used was the one from scikit-learn. And Nyakio prepared a very cool example of a Llama Cartesi dApp. The way it works is it takes a quick exit using GIO to simulate how it would be to use Llama on the coprocessor. You're not running Llama directly on the Cartesi machine, but you are using IO to communicate with the host machine to run the model there. It's a very interesting way to write proofs of concept on how to do that. And based on this, Enrique from Developer Advocacy created 2 applications that you might also want to use as a template, which are these 2. YoLove 8, which is a very, very cool one that, to quickly show, you basically have a carbon credit token, which when you update an image of a tree, you can run a carbon credit calculator, right? And after this calculation, the image is sent to a machine learning model, which processes all the information. And of course, it gives you back tokens for carbon credit given what you mapped. And of course, an inner in-depth tutorial of how to use the Llama agent that Nyakio posted. So yeah, have fun, watch the videos, see how they work, use them as inspiration. And as Felipe mentioned, I think the most important thing is test, give us feedback, and show us what your crazy minds can bring to life. So that was what I have.
Also, I really like the tree application. Was not expecting that.
Yeah, that's a nice one. We love that example.
So that's it, guys. We're wrapping up here. Any last comments? Cool. So oh, sorry, you're muted, Erick.
I said, let's have fun and build.
Let's have fun and build. So any questions, concerns, Discord will be there. And it was lovely. We're ending up right on time, so everyone can go have lunch, breakfast, or dinner, depending on their time zone. And for those skipping the meals to hack, take it easy. All right. It was great, guys. Thank you so much for this, and see you during the week. Let's go.
Bye-bye.